Hello, this is the second video on hybridization. We'd like to look today at the bonding that's taking place in an ethene molecule. So 2 carbons, 4 hydrogens, and a double bond. So let's look at this, these orbitals that are formed. We want to remind you guys of the orbital notation for carbon. We're interested in these 4 valence electrons. So you see with the structure, we have three electron regions. This is trigonal planar. So if you see trigonal planar, you should think sp2 hybridization. So let's look at this carbon here. What will happen is these orbitals will hybridize again. This time we'll form 3 hybrid orbitals. These are the sp2 hybrid orbitals. And then you'll notice the difference between this and sp3 is we have an electron left over. And that electron is still in that 2p orbital. So this is what we're working with here. So let's remind you guys again of what an s orbital looks like. It's spherical. This time we're going to add 2 of these p orbitals, and we're going to get 3 sp2 orbitals, and they'll look something like this. All right, so let's look at this carbon right here and draw. We'll just draw the carbon here, and let's draw these 3 sp2 hybrid orbitals. So we'll draw an orbital like that. We'll draw orbital here, and then here. Again, these will each have 1 electron, so let's put an electron here, electron here, electron here. Now we'll look at this carbon here. Put this carbon here. These sp2 hybrid orbitals will overlap, and then we'll have these orbitals here, and these will form sigma bonds with those hydrogens. Let's form those sigma bonds with hydrogens, okay? All right, that's a sigma bond as well, right there. So far we have 5 sigma bonds. So we're missing some electrons though. So how about this guy? Well, this electron is in an unhybridized orbital, a p orbital. Looks like this. And so let's put that orbital right here. Of course, there's an electron in each of these. Now, what you'll see in textbooks is you'll see just little lines drawn here. But I learned from Mr. McAfee that's probably not the best way to describe this. So let's look at it a different way. If you're this electron here, you're going to be attracted to this nucleus. Same with this electron. So what really happens is these p orbitals overlap. So there's some bonding that's occurring that's referred to as being delocalized. And this is what's called a pi bond. This is a pi bond. In this structure, we have 1, 2, 3, 4, 5 sigma bonds and 1 pi bond. That's sp2 hybridization. I think that's all I want to mention. Again, if you think about the geometry around this carbon, it's trigonal planar. So if you see trigonal planar, think sp2. If you see tetrahedral, think sp3. If you see linear, you're going to think sp2. That's the next video. All right, we'll see you. Bye.